Hey everyone! Have you ever tried to learn how to code but got stuck? In my new Python programming class, we're going to break that loop. This course is primarily focused on people who are complete beginners, so don't worry if you don't have any background. This course is different than other courses because we're going to teach you to think like a programmer and solve problems like a robot. So let's get started. Hi everyone, so now we're going to start digging into how we're going to try to solve this problem using Python. Now, if you remember last time, what we were talking about is the quadratic equation and the quadratic formula and trying to find the roots of this equation, explaining why we might want to do that and what our approach is going to be. So as I mentioned last time, our quadratic equation or our parabola is going to look like this, and we're trying to find these values where it hits the x-axis or where y is equal to 0. So the way that we've discussed doing this is by doing a guess and check method and plugging in a whole bunch of things here. And that worked for us. We were able to find that ourselves without using a computer at all. But we realized if we made it a little more complicated, it might be a little bit harder to do. So first thing we're going to do is actually, instead of calculating this ourselves, like 4 squared minus 3 times 4 equals 4, we're going to try to do this using our computer as a calculator. Python can actually calculate numbers for us, right? So rather than us having to plug these in ourselves, we can use Python as a calculator. So in order to try this out, so let's say I want to try this number out here to try to use this formula and plug in a number for hours of math like we were doing before. Plug in a number and check if it's 0. I'm going to try that with 1, and I'm going to use Python to do that for me. So the way that you can do math in Python is very similar to the way that you do math in a calculator. So if I can use parentheses and I can use different arithmetic operators to perform operations. So first thing I'm going to do is I'm going to write this out. So I'm going to say 1 squared minus 4 times 1 plus 7 divided by 4. I'm just doing this to show you how we can replicate that formula up there using 1, right? So I just plugged in 1 here. So hours of math is 1 squared minus 4 times 1 plus 7 over 4. This is how we do this in Python, and it's pretty much like a calculator works, right? So we have some symbols that represent certain operations. These 2 asterisks here represent exponentiation. In this case, we're squaring it. You might, in a regular calculator, you probably have seen something like using a caret. So 1 to the 5th power. In Python, this doesn't work that way. What you're going to want to do is use these 2 asterisks to represent exponentiation. But everything else is probably something you've seen before. So you can use a asterisk to represent multiplication, so 4 times the hours of math. And you can use a plus to represent addition, so plus 7 over 4. A minus to represent subtraction, a minus here. And a slash to represent division, so 7 divided by 4. So you've probably seen this on a calculator before if you've ever used your computer as a calculator. So it's not super surprising how these work, but this is how you use Python as a calculator. And you can also use parentheses to separate sections of your addition and subtraction. So as I mentioned, you could do addition, like 3 plus 3, and you run that and you'll get 6. You can do 5 minus 2. You can run that and you'll get 3. Negative 2 times 15. You'll get negative 30. And 3.5 divided by 123, you'll get 0.028455. So we're basically just using Python as a calculator. That is also valid code, right? Using the same kind of math that we might put into a calculator is the same thing as it's also code itself, right? So that's great. So you already know some code, actually. You probably have already used this, but if you haven't, this is how you would go about doing it. One thing you might want to note is that just like a calculator, your Python will use PEMDAS. And this is something you probably have learned at one point in your life, but might have forgotten. PEMDAS is the order of operations of math and arithmetic. PEMDAS stands for parentheses, exponentiation, multiplication, division, addition, subtraction. And that's basically the order that you will perform arithmetic in. There's some ambiguity as to what order you should perform some operations. So for instance, if I did 1 plus 3 times 5, the answer is going to be different depending on if I use multiplication first or addition first. So PEMDAS, P-E-M-D-A-S, tells you which things have priority. So in this case, multiplication has priority over addition. So you're going to get 16. So you're going to do this part first because multiplication is prioritized. And then you do this part second. You get 16. So PEMDAS is this kind of framework for the priority of arithmetic operations. If you'd done it the other way, if you did addition first, you'd end up with 4 times 5, which would be 20. So that's one thing to keep in mind, is that Python will follow and abide by the rules of PEMDAS. Now, you can use parentheses. That's the first letter of PEMDAS. So I can go 1 plus 3 times 5. And now I'm going to get 20. So you can separate things off with parentheses. If you're ever in doubt, something I always do is just separate things off in parentheses anyway, just so it's easier and you're not relying on yourself to type it in the right way. This is something that can oddly cause errors that you might not be able to realize why it's happening. Because of PEMDAS, I actually shouldn't have to do any of these parentheses here, right? Because everything inside of here has priority over addition, subtraction, multiplication, and division, right? And I don't. It ends up coming up with the same result. But I find this kind of confusing. So as I mentioned before, I'm always going to put parentheses around things just to make sure that I have it right, because it's easy to mess up. And you just don't want to be thinking about PEMDAS every time you're writing any kind of math in Python. So those are arithmetic operations, something that you're probably familiar with just from learning arithmetic. Now there's other types of operators, these kind of comparison operators or logical operators that handle logical operations. Logical operations sound complicated, these comparative operators, but they're really pretty simple and something you probably learned before. So what these are things like greater than, less than, equal to. So if you do 3 is greater than 2, we know that this is something that's true, right? 3 is greater than 2. And what it will return is a Boolean value. Boolean values are true or false. Those are just represent the truth value of a particular statement. So in this case, we know 3 is greater than 2, so we know that's a true statement. If we were to say something like 7 is less than 5, which is false, we would get a false. So those are the only two possible values that can come out of this. So that's greater than or less than. We use the same symbols that we would do in math. You can also do greater than or equal to. So 3 is greater than or equal to 5, which is false. Or 7 is less than or equal to 2, which is false. But you can also do equality. Now, you might think that equality would be something like 5 equals 5, but this doesn't work. The reason it doesn't work is because that equal sign represents something very specific in Python. It represents assignment, and this is what this is saying. First off, nice thing that we're going to figure out is what an error looks like. So when we place something in, or we type something in that Python doesn't understand or doesn't work, it's going to come up with an error. In this case, it's a syntax error. Syntax refers to what the computer can actually understand, right? And if you say something that is not able to be performed by the computer, you're going to get a syntax error, something that Python says that's not valid Python code. So this syntax error in this case says can't assign to a literal, which means that Python's trying to read this and it says, I can't understand this. This is incorrect Python. You're not supposed to use Python like this. And you're not. This is just one thing I want to point out. So an error will come up like this. It will tell you where it happened. You'll see in a Jupyter notebook, you'll see IPython. Don't worry about this, but it will show you the line of code. 5 equals 5 is the problem. And it says, hey, syntax error, I can't assign to a literal. Don't worry too much about what this means. Sometimes these can be a little bit cryptic. But in this case, equal to is usually used as an assignment operator, which we're going to talk about later. In this case, we don't want to use assignment. We actually just want to say equal to. To do that, you use 2 equal signs, and it will give you, again, a true or false value. So here, 5 is equal to 5. It's going to come up as true. 4 is equal to 5 will come up as false. Now, one additional thing you might want to note is that we also have a not equal to operator, which does the exact opposite of what the equal to operator does. So the way that you would do this is with an exclamation point. If you do 5 exclamation point equal to 5, you'll get false. And likewise, if you do this, you'll get true. So it's basically 4 is not equal to 5. That's true. You might remember when you did this in math, you would use an equal sign, then you just slash it out. You can't do that in Python on a keyboard, obviously. So the way that you would do that is with an exclamation point. Okay, so this is just going over a lot of arithmetic operation, logical operations in math that you can use as Python as a calculator. Now, there's a couple of more advanced features that you may have remembered, you may not remember, you may have never been taught in school that I just want to go over because they're important in programming. And don't worry, again, it's not that much math and it's not going to require you to know anything very complicated, but it's something you probably haven't seen before that is actually very useful when you're writing programs. So the first thing is exponentiation. I'm sure you've seen this to some degree. A lot of people don't use it as much anymore. So exponentiation is multiplying a number by itself a number of times, in this case 2. So that's squaring it. 4 squared is 16. But you can also do roots using exponentiation. So if you want the square root of a number, you can do the number to the 1/2 power. So 1 over the number you want to find the root of. So the square root of 4 is 2, and you could do it this way. Not that the exponentiation, you use those two asterisks, as I mentioned before. Not that you probably have heard of exponentiation before. You might have heard of exponentiation before, but it's just something I wanted to clarify. If you want to find the square root or a quarter root, you always just do the reciprocal of the number. So 1 over 2, or a quarter root be 1 over 4, and use that as the exponent. Python will do exactly the same thing, just like a calculator. The other is floor division. So floor division is probably something you haven't learned in school because it's not as useful outside of programming as it would be in math. It's not that as useful in math as it would be in programming. Floor division, you use 2 slashes, like the division slash, but you use 2 of them. And what this will do is it just returns the largest integer less than the result of the division operation, which sounds a little complicated, but really all it does is it takes away the decimal point from a division, or it takes away the remainder from a division. So in this case, I take 5 divided by 2. 5 divided by 2 is 2.5, right? 2.5. Most of us probably are familiar with that. Floor division will just get rid of the decimal point. So it just will say 2. 2 is the largest integer less than 2.5, right? So that's what floor division does. It gets rid of the remainder. And like a complement to this is modulo. Modulo could be a little bit complicated to understand at first, but the way that modulo, I think the best way that I think of modulo in relation to this floor division. So you might remember when you first learned about division, you learned about remainder. So rather than doing a decimal point, you would learn that something was like 5 divided by 2 was 2 remainder 1, because there was 1 left over after you divided it by 2. Modulo and floor division actually work with the same idea. So floor division got rid of the remainder. Modulo, what it's going to do is it's going to perform the division and then return what the remainder would have been if you divided by that number. So here in this case, we're going to get 1. So 5 modulo 2 is 1. So 5 divided by 2 would be 2 remainder 1 if we use that remainder. And then we just only return the remainder. In some ways, floor division and modulo are 2 sides of the same coin, right? The floor division just gives the first part of that, the part without the remainder, and the modulo is going to give you the remainder. Now, don't worry too much about these things. I just wanted to show you how you can do them. So in Python, you use the percentage sign for modulo, these 2 division signs for floor division. Just in case you see this out there when you're writing code, they're very useful in programming, and I'm not going to get into why just yet. When we do get into that, I'll talk more to it. But these are just some things that you might want to be aware of as we go forward and we start learning things. So all of this was to discuss using Python as a calculator. So now, instead of having to do this manually, writing this on a pen and paper, we can start plugging things in for numbers here. So we tried to solve this equation using 1 for hours of math. That's what this was. And we could start doing this for other numbers as well. So we could plug it in. I just copy and pasted it there, but we can plug in 2 here. So instead of using 1 squared minus 4 times 1, I use 2 squared minus 4 times 2, and I run it, and I'm able to solve it that way. So just makes things easier of how we're able to use arithmetic in Python to solve this same problem. Okay, great. Now that we've discussed that a bit, we're gonna stop here, and in the next video we're going to talk a little bit about how we can make this even easier on ourselves rather than having to replace these numbers each time we check it.